Hi, good morning. So when I tell you that I want to talk to you about embedding electronics into the environment, you probably have some vision of this in your head, right? A lot of complexity, a lot of wires, and a lot of individual devices. But as you're probably not surprised to hear, we have a very different vision for how you can embed electronics into the environment, into products, and into packaging. And that vision is founded around a smart material. This is our electrically conductive paint. We sold over 400,000 units of this material. And we built a technology stack on top of it to transform it from just a material technology into a sensor technology that has a really wide set of applications. So let's talk about what I really mean by a sensor technology. We mean any surface smart at any scale. So what is that? Any surface really means that any surface. So we're almost totally agnostic to the materiality of the surface. We can work on paper, plastic, wood, cardboard, and we can work in lots of different environments. Automotive interiors, packaging, buildings. Smart means a sensor technology that can detect things as small as an insect to as big as a person. We're also really good at detecting fluids. And at any scale, it's probably the most important thing that I'll talk about today. We're leveraging manufacturing processes that make it possible for us to cover very, very large scale at very low cost. And I'm happy to talk to you in detail about that later and where these numbers come from. This is what we do. This is probably the simplest version of what we do. Well, the video isn't working, so I'll talk you through it, and I'm happy to show you a live demo later as well. So what we do is we transform surfaces. So as I said, we start with something like paper, plastic, wood, cardboard, glass. We're almost totally agnostic. We print our electrically conductive paint. You can think of this as printing a camera lens. What we print, the pattern, is really important. We add our hardware, which is a bit like adding a camera body. We then power up this surface to generate an electric field that we manipulate and measure. So some of you out there will probably say, hey, that's capacitive sensing. It's true, we use capacitive sensing as part of what we do. That field can then detect a huge variety of targets. The smallest target we've ever detected is the first instar of a cockroach, so that's about 2 millimeters long. We don't do that all the time, but it's pretty exciting. We typically detect things like people and fluids. We can detect those in 3 dimensions as well, so we're able to know where something is in the space. It also allows us to classify gestures. We classify those events on board, and then we send them wirelessly, so we can work with a lot of different formats. But most importantly, and the thing that I'd love to show you later with the live demo, because there's really no replacement for it, is that we're able to project our field up to 1 meter away from the surface. So that gets us really good proximity detection of the target. But it also means that we're able to cover the sensor with another material. So effectively, we can hide it. And that's a really important function for us. We think that this technology will make the world smart as we build it. Rather than adding electronics and adding intelligence onto products, we should be building it into products from the very beginning. And we share that vision with our partners and with people who are in our pipeline who are focused on 2 major verticals, or I should say 2 major technical implementations, which is interfaces and occupancy. Interfaces essentially being adding buttons and controls to surfaces, and occupancy being passively detecting the presence of a target, so that could be a person or a fluid around that surface. So I hope that I get a chance to talk to some of you today about how we can work with you and solve some of these really sticky problems that we think that smart surfaces can serve. Thank you very much.
Any questions? What is the use of your biggest deployment?
What is our biggest deployment? So in terms of our biggest deployment from a field trial perspective, we've got 5,000 units of a bed bug detector currently in hotel rooms in the States. So that demonstrates the scale of target we can detect. Bed bugs are typically 2 to 5 millimeters in diameter. And just to be specific, that deployment is actually a sticker-like product that gets applied to a hotel bed.
And have you detected it?
Yeah, and if you and for $20, I'll tell you which hotel. Yes, we have. So we've detected bugs in the lab and in the field. That's at the extreme range of our resolution, but I think it's a wonderful application because it demonstrates how we can achieve such high resolution with a really low-cost product. So it's literally a a big sticker that you put on the back of a hotel bed. And we're delivering that to market with the pest control partner, which is the model that we aim to achieve.
And what about hospitals? Do you have any applications in hospitals?
So we do have some applications in hospitals. We have a couple of partners. One rather spectacular partner who's very focused on that. And we think that there's a lot of potential there because we can detect people passively. We can also detect whether surfaces have been cleaned and touched, which is really important. Yes?
Have you done pesticide detection, grain silos or anything like that?
That's interesting. So we looked at doing a kind of relative humidity measurement for bulk products. Yeah, but without knowing the chemistry of the pesticide, it's hard for me to gauge what our level of detection would be. But if you want to talk in more detail later, I'd be happy to do that.
All right. Well, thank you, Matt.
Thank you very much.